In this video, we will show how to do shiplifting simulation by our software OLTranSim structure. Shiplifting simulation is simulates the process of to build a whole ship by one block by another block. Each block is lifted first and moved to the whole ship and assembly. So we just simulate the block lifted process. In shipbuilding industry, we always simulate this process as static analysis, and we always just trim some block from a whole CAE software. The whole CAE model is something like this. Is a cabin CAE model, just for the detail process or other simulation problem. So we just trim some block from this model and add some lugs on the decks and add some ropes and simulate the gravity effect on the lifting. So let's begin. After imported this model, we will choose some block. First, we will set this block as a set, element set. We rename it element set. Just okay, just this one. First, we will change this block. So just remove from 3D view and delete other elements. It's no use. And also some free node is deleted. Okay, we will handle this block. And first we will translate it to the original point and create a point by 0, 0, 0 and translate this block to this original point, and from just click move from this point to this point and merge nodes, because two nodes are coincident. Before we install log, we have to remesh this big mesh. Just choose mesh refine and select the dimension. It's mm unit, so we choose dimension 15 mm. And these 2 points will be remeshed. We will create 4 logs, so there's 4 areas. you will see it has some fine meshes, and we will create logs from line to shell. Just define some parameters. DJ is 15 and times is 10, and from we will choose some edges, but if you want to choose edges one by one by click, it's very hard. So we could do it by choose edges by node path, and from this point to this point. So program will select edges from between these two paths, two nodes, and click done. That's all. Then we will create a horse. The hole is will be lifted by rope, and the rope will through this hole. Just the opening mesh. There are several types: circle, manhole, rectangle, or round rectangle. So we just choose a circle. 100 radius and 25 mesh size. That's all. We will define the center of the circle. Just this point, and define the plane by 2 points. Click OK. The hole will define automatically, and another side, just a similar way. Then we will add a material and depth to this log. We will create two sections. One is section for this area. It will add some depths, and another is for the others. So just create two sections. This one is add depths. Choose the shell, and the thickness is 22. We will assign this section. By choose the hole, the element around the hole, just choose a circle. By individual. And if you want to choose another circle, you have to push Shift keyboard. Okay, that's all. Select the section we just created. You can select sections color. You will see some elements color is changed if it is assigned sections. And then we assign the other sections for log. Other depth is 20. and we will select by angle. One. Just choose log other. Oh no, you have to delete the elements around the circle, so just delete it. And we'll do it again. Select all, and unselect the whole. Just push Control keyboard to unselect it. Select down. Okay. Oh, it's okay now. The material and depth is assigned for this log, and we will copy this log to the left bottom, just like this one. Copy, translate. Okay, after select, just copy once, and we will copy properties. So we have to set properties before copy. From this point to this point. Yeah, it's this point. Just click continue. And after we copy, just merge a node. The log is created, but we add if we add some force by the other side, the log is weak to this kind of force. So we add some blanket to strengthen this log. Just click corner block, corner blanket, choose 450, choose the center of the corner, and the other 2 points on the plane. Just OK. It couldn't. Let me see. Okay. It will choose there are another 2 blanket. select the center and the other nodes. Okay, and also set this blanket to some material and depth, just like the operation before. Select select the for blanket. Click down and also choose log others. And merge some node. Okay, then we will copy these two logs to the right. First we will translate. Just select or choose the rectangle select. Select all logs and the brackets. It's right. Okay. From this point, select the end point. Oh yeah, this point. Just click OK. Continue. You will see the two logs is copied to the right, and just do merge nodes. Okay, all logs are created. Then we will create loops, and there are 3 points of log. The loops are lifted from the loop point. There are 3 points. Lift point. 3 lift point. One is lifted by these 2 legs, and another is lifted these 2 legs, and the third point will lift these 2 logs. So we will first create a lifted point. Oh, not by midpoint. Just create a point from 2 points. Select the 2 points and we will create 8 center of the circle. Then we will create 3 points for the lifting points. Between these points, there's 1, and these 2 circles, there's another 1. Then the third one is around 6 points. So we just create by 6 point to this point. Okay, and we will transfer these points to the upside. Translate 1, 2, 3. Yeah, move to 20 meters. Okay, the left point is created. Then we will create loops from this point to the log center. Just create truss. We will use a truss element to simulate loops from this point to this point. Click send point of the mouse to finish it. The 7 loops, and the last loop. After create loop, we will create a loop section. Just choose the truss and set section areas 500 and assign sections to these loops. Choose the loop. Okay, you can just check if it's great by 3D view for the beam profile. Okay, it's right. Then we will connect this end of the loop to the log by interaction. And we will just create a coupling from this point to 3 point, just up the end of the loop. Click OK, and the second. The third one coupling. We use the K coupling to simulate the interaction of the loop and logs. It's very strong. And there's another side. There are also 4 constraints to set. It's a similar way. Okay, it has two coupling left. The last one. Okay, I think we created everything of the model. So we just simulated, and for the static analysis, we will create a static analysis. But when we imported the PDF, Nastran PDF file to this to OLTranSim, it will transfer the PDF steps to this to OLTranSim step. You will see it as a static analysis step, so we wouldn't create again. And but we will create a load and boundary condition. First, we will create a boundary condition, just as usual. We will bind fix these 3 points. We use this one. It's more convenient. Click in const, and we will check the mass center and set some boundary for the center. We will show query mass. You will see the total mass is 74 ton, and central mass is 7,000 and 0 almost, and the C coordinate is negative 500. So we will select a node near this center of the mass and add some BC. So because it's a symmetry structure, so the center of the mass is almost in the center, just like this way. Almost this way. Yeah, almost this way. Oh, not this way. Oh, this way. We will set boundary conditions of x and y fix for this node instead of center of the mass. It's the same, almost the same, because the structure is on the gravity load, and the gravity is always drag the structure to the z axis. So it has a little effect to fix the UE and the UR on this point or by center of the mass. So just create this point to UE and UR. Okay, the boundary condition is created, and we will create a node load. We will just simulate the gravity effect and continue, and set the gravity. We will add some safety fraction 1.1. So we will set this value. Okay, and as a load case, we have to add a load and boundary condition to this load case. Okay, the model is created. And we will simulate it. Just create a task job. And select the job to submit it. Submit. It will call our solver to simulate it and calculate the static analysis. It will spend some time. I think it's in about 3 minutes. So I will say something about this model. This model is I think it's symmetric from left or right and top and bottom. So if we don't add this boundary condition, this structure could move around the xy plane and from this way or this way. So we will fix the x and y translate, and there's some if the structure is not a symmetry very well, it will rotate around the z axis. So if you want to your problem has your model has this problem, you can fix the UR3 means fix the rotation of the around the z axis just at this point. To this boundary condition is to aim to fix the whole model's DOF. Yeah. We will check. The solver's message is printed under the command line. You could see all the places of the solver. And first we will check. We will read the elements by beam or truss or some elements of shell. And we will analyze the load case. In load case, we will simulate the load and boundary conditions, and then call the matrix solver to get the displacement and stress. Okay, and print some results in this blank window. Okay, it's finished. Then we check the results, and the result will be imported to the post-processing, and we will check the displacement, magnitude or just displacement around the z-axis, or just reaction force or reaction moment, or the most important strength. We will show mistress, and just click this button to show the largest process. It's around this way, and we can show the center point stress It's more reasonable than the node stress just now. It's almost 300 MPa, almost beyond the it's beyond the yield point, and it will destroy at this model. It's very dangerous. So that's all our functions to simulate lifting process of the ship And if you are interested, welcome to use this software OLTranSim to do simulation. That's all. Thank you.